Um, so we've had an opportunity, the last sprint, few sprints, we talked about building an API on the back end. So we've had a chance to dig into Node. We've had a chance to dig into Express. We've learned a lot about, how to design an API, the different REST and HTTP methods that are used, and so forth. And throughout all of that, a lot of the repos that we downloaded and used, we noticed that there were a lot of data access helpers that, I kept telling you we're going to learn about that later. Well, these are the sprints where we're going to learn about that. We're going to talk about a concept called data persistence. And it's really a huge topic. People make entire careers out of working in data. And there's lately, when I say lately, relatively lately, an entirely new class of legitimate data architectures that have come to light. During these sprints, we're going to talk about relational databases. Relational databases have been around for a very long time, and they're still incredibly useful. But there are a number of use cases in the cloud and different approaches to how to handle data and database design that have given rise to some other concepts that have existed for a long time as well, but have never really been used in production or in real systems. But now they are. You may, as you've learned, as you've gone through the training kit, we're going to do just a brief overview of that now. You learned about something called SQL or SQL, Structured Query Language is what it stands for. And that's basically a common language that describes how to manipulate data in relational databases. And it has features in the language that allow you to perform all the CRUD operations, but with some really sophisticated capabilities in terms of taking different collections or different tables, data tables, and relating them together. And some of the things that we'll see in terms of some of the practice systems that we'll look at are designed as relational databases. At some point in your career, if you dig into data design, you'll learn about something called normalization, which is really an effort to simplify data, the way that data is stored, so that you don't have duplication, you don't have multiple places where you have to update certain things when things change, as data often does. We won't dig too deeply into that, but we are going to get into a little bit of that as we go forward. We're really going to kind of touch the surface, and in particular, we'll talk, and especially today, we'll get into how we can take a database and connect it to our API using something called a query builder, which is essentially just a JavaScript front end to building SQL statements. So let's just kind of briefly go over the data or the information in the training kit. Yes, Connects is our query builder. So Ali asks, when you set up an app and launch it, where does the data store physically? And I like that question, and I'll tell you why. The way that I've always approached making hardware and software do what I want it to is I try to think like it. And it's kind of made me a little bit of a weirdo, but I have a normal life, so I'm happy with that. But I do think about things a little differently. And that's one of the questions I always like to think about is ultimately, where are the bits and bytes? And what's touching them? So when you think about databases, ultimately, even if it's in the cloud, I always used to tell people the cloud is just other people's computers. That's really all it is. And when you look at databases, very often you'll hear about something called a database server, and your software will interact with the database server using a protocol not terribly unlike the API that we've been writing. In fact, many databases today do support a REST API. Historically, they haven't. They've had other types of APIs that allow you to access centralized data across a network. But ultimately, data is stored in, on a disk drive, in a computer, behind a server. And in the system that we're going to work with today, our database is actually just a local file. It's not actually on a server. It's not across the network. We'll be connecting to it just by opening it like we would a Word document or any other document that's on our local machine. So again, the concept of data persistence. Persistence really means things that don't come and go, but they stay. And so when your application stops running, when the machine that it's running on stops running, and then you start it up again, the data is still there in the state that it was in when you left it. So that's what persistence is referring to. And then in relational databases, that data is stored in tables. The name table, I think, has got some historical context. It essentially means a row and column format, where the columns represent properties on a particular object, and then the row represents an instance of that object with values for those properties. And so a table then would represent a particular object, and if you had different objects, you would have different tables. So if you think about an order management system, for example, you would have one table that had rows in it that represented customers, and another table that had rows that represented orders, and another table with rows that represented products. And each of the columns in those tables would represent different properties on those objects. And it's helpful to think about that and keep that in mind. As we go forward, it's really all, when you think about a table, that's all it is. It's just a row and a column format, just like a spreadsheet. You might consider a spreadsheet is really just a special type of database if you think about it. Okay. I hope you have had a chance. If you haven't, encourage you to do the dig deeper exercise off the training kit and look at the SQL tutorial. There's a lot. It could be a very deep topic, and especially when we get into trying to combine chunks of data that are in different tables, and in some cases even in different databases, and present the combination of that information as a unified whole to a piece of software that needs to process it or do something with it. It can get pretty complicated as you dig into it, and again, we're not going to really dig too deeply into the complicated parts. But there's plenty of out there for you to learn. And some people, like I said, make an entire career out of that. So you would have learned about the select statement. We're going to dig into some more of the CRUD operations in the syntax of SQL. And we'll talk about connects tonight. By the way, I find it really interesting. I'll give you just a really brief story about me and my history, and some of you know my brother Brian is also an instructor here at Lambda School. We got our start back when we were in high school, back when computers were just barely a thing in homes, in the consumer market, back in the early 80s. And the internet was still, for the government and for the military, and the way that we connected with other people was through what back then was known as bulletin board systems, or BBSs. And we used modems to dial up and connect to a server that different BBS operators would set up for that purpose, and they would host data. It's not unlike a web server, but it didn't have the interconnectedness. So when you connected to a BBS, you pretty much were connected to that, and you only had access to what they had. But the interesting thing about that whole environment is that you didn't really talk to people. You only read what they wrote, and you wrote back to them. And so it was all by text. And you had this entirely new language that came about that you didn't ever get to hear people speak. And being a kid and not being in the work world, I didn't understand exactly how networks worked and what different jobs were like in that field. I just knew I loved what we were playing with. And there was, I kept reading about these SysOps that existed in the computer, in the the networking, network management, BBS management world. And it was spelled SYSOP, and that's how I learned to pronounce it, was SysOp, because I had never heard anybody actually say it. It was only years later, after I had been actually working in the industry for quite a long time, that it dawned on me that those were actually SysOps. They were systems operators, and SysOp was just a short form of that. And because of that experience, I always I'm kind of anxious about knowing how to pronounce things. And so I've heard different people talk about the Connects system as Nex, because in English we're used to pronouncing KN as the K is silent. But I've heard the creator of Connects actually speak about it, and he pronounces it Connects, so I figured that's good enough for me. So that's what I call it, just a FYI. Doesn't really matter that much, but I thought you might want to know. Anyway, let's move on. Okay, so you've had a chance to go through this. We're going to dig into this some more. Hopefully you've had a chance to clone and fork and clone the repo. We're going to get into that in just a little bit. But first, what we want to do is kind of jump into the W3 Schools SQL Try It tool. So if you want to follow along, you can go to w3schools.com/SQL. And what they have here, if you click on the Try It Yourself button, it'll open up a SQL editor and the ability to run it. So the default one here is select star from customers. If you look over on the right, you'll see a number of tables that they've pre-populated. And if I click on run, to select star from customers, you will have learned again in the training kit, star is a global syntax that means return all of the columns, all of the data from this particular table. And so when we do select, we're doing a read in the CRUD operations from the customers table. And then it'll return it and format it again in tabular format here. Just by way of curiosity, you can see if you go into the developer tools and drop this down, if you don't see the application tab and choose application, you'll see a database symbol called Web SQL or Web SQL, and then you'll see the W3 Schools demo database that's downloaded here. And so essentially what happens when you load that page, it downloads a chunk of data in the Web SQL format and stores it locally in the browser's storage. And so each of you, as you load this page, you'll have your own local copy of this database that you can work with. And that's why, if you completely empty all of the data from your customers table, it won't impact anybody else. And you'll notice as well, they've got this restore database button that will allow you to put it back into its initial state if you manage to destroy things, which I do all the time. So in any case, so you can do a select star from customers. And again, the star is a global syntax that means return all of the columns. And so just by doing that, we can see what columns there are in the table. Customer ID, customer name, contact name, address, city, postal code, and country. If we don't want to return all of these, we can actually specify what columns we want. We might say customer ID, customer name, and city. And that will limit the data that returns to just the columns that we're interested in. From a data software management perspective, that's useful because it allows you to limit the amount of data that gets transferred from the server, and it can impact performance for the better. And it also just makes things cleaner in your code if you're very explicit about what it is that you're trying to do. The other thing that we can do to kind of limit the amount of data or what data comes back is, in addition to limiting columns, we can also add a filter. And we're very familiar with that in other products that we're used to using. So for example, I could say, select those columns from the customer's database where city equals Berlin. Then if I run that, you'll see that we have one customer that has that as the city. So we're able to, again, filter it down using this where syntax. And one of the things that you will have noticed about SQL as a language is it reads in a very intuitive way. So the actual command that you're giving is very much like an English sentence. Select these fields from that table where this is true. And but then using syntax, we can make these more complicated. So for example, we could say where city is not equal to Berlin. And then we can add another statement and say, and customer name Then I'm going to use another SQL operator here, which is the word like, which basically means is similar to. And it's very liberal with this. This way you don't have to worry about case. And there's another character that you can use, which is the % that is a wildcard. So if you're familiar with managing files in a file system, in a disk operating system like a Linux or Windows, then the wildcard for global is an asterisk, but in SQL it's a %. So we might say, let's return everything that is not from Berlin and that has a customer name that has an AN in it somewhere. Oh, I forgot to put my closing thing there. So now, if I go through and look at my customer names, you'll notice every single one of these have an AN in it somewhere, right? Because we removed everything. In fact, just to kind of make it a little more, we can say, you'll notice this Ernst Handel, record number 20. Even though Ernst is going to match this, he will not match this. So the entire where clause is going to be false, which will mean he'll be blocked out. So you'll notice that he's now gone from the list there. Josh was asking, do we have to keep it in order column name-wise? There's an answer to that question. It'll just display in the order that you write it out, which is correct. So the order of the columns in the table are unimportant to us. We're able to direct what order we want them to be returned in for our own purposes. The order you select in affects the order of the columns returned. Great, thank you for that answer. And bye-bye, Inist. That I probably spelled that wrong. But yeah, exactly. Okay, so that gives you an idea of how select works. And a little bit about SQL. It's just kind of a review because I think you went through this in the training kit a bit. Okay. So what I'd like to do is give you a couple of minutes, just a little in-class assignment. Take a minute and create a query that will list the products that have a category of 2. And then post the number of records that you return in the chat so others can see. And then also write a query that will return the name, just the name field, of the record in the categories table that has an ID of number 2. So we know the ID is 2, we know the table is categories, but we want to get its name. Yes, I will type these out. Okay, so I posted those assignments in the chat. Thanks for calling that out, Mandy. I'm actually hoping to work more visuals into the way that I teach, but this is my first time doing it, so I'm still kind of refining that, but I appreciate the feedback on that. Not everybody is an auditory learner, so thank you for that. I'll just put a quick yes, no in here and let me know when you're ready to move on. Thank you. Okay, be sure and click no if you're not ready, and then go back and change it to yes if you are, and then we'll be able to move on. Okay, so I've done an example of the query for the first assignment here. I didn't know exactly what fields there were in the products table, so I just did a query, returned the category, the entire list, and saw that category ID was the name of the field. Then just added a where clause for category ID equals 2. You'll notice that I'm typing now in all lowercase. That's not typical when you're talking about SQL. I'm being a little lazy, but partly just to show you that even though SQL is a kind of a standard, you'll find different vendors and different database products that will implement it in different ways. And here, not enforcing or requiring uppercase for the keywords as well as case sensitivity in the table names works to my advantage because I'm kind of a lazy typer. Okay, let's move on then. The next thing that we'll take a quick peek at is the order by clause. Okay, so sometimes when you return data from a database, you want it to come back. So we talked about how you can reorder the columns in different ways, but sometimes you also want the rows to be in a particular order and have them be sorted by the values in a particular column. So in this case, for example, we could do select star from products, order by price. So this way it'll sort them by the price. It turns out that the order by operator can take a modifier which will allow us to force it to sort in ascending order or in descending order. By default, it works in ascending order, and in the SQL language, ascending and descending isn't completely spelled out, it's abbreviated. So you can see select star from products, order by price, ASC. That's the default. You'll see we get the exact same list back. So ASC, you don't have to include it, but if you wanted to order it in descending, then you use DESC, and you'll notice that it sorts them in descending order. Okay. Pretty straightforward. And then other things I could do with that, I can combine these different clauses together. So these filter clauses, I've got my command, I'm selecting, I've got my list of what I want to select, where I'm selecting it from. I could put a where clause in here. Maybe we want to say where the price is greater than 50, and then order that in descending order. And so that's going to limit us to a number of 7 records, whereas before, if I take out the where clause, we had 77. So so these can be combined, these different clauses can be combined in your SQL statement. Okay. And then the next operator we'll talk about is the limit operator. So sometimes you only want a certain number of records to come back instead of getting all of them. And you'll run into different instances where that's useful. So remember before, when I didn't have the where clause, we were getting 77 records back, but maybe I only want the top 5. Right, so I could say limit 5, I wanted the 5 most expensive products. And that will limit our result set to just the 5 records, and I have it sorted in reverse order by price. And so I'll get the 5 most expensive products there. Okay, hopefully you guys are able to follow along with this. So we've talked about a number of different ways we can read data from the database. That's the R in CRUD, right? So reading data, selecting different pieces of data that we're interested in, ordering it, filtering it, and manipulating it that way. Next, let's talk about the C in CRUD. Okay, this is how we create data. How do records get in there to begin with? The SQL command that we're going to use for that is called insert. Okay. So when we insert, again, that's the command we're giving. We need to give some information about where to insert, which of these tables we're inserting into. And so let's insert into customers. And what we can specify to the database system is what fields we have values for. So what are we going to be supplying here? Now, one of the things I'll mention here is you'll notice that each of these tables has an ID column of some type. Okay, the name is arbitrary, but when records are created in that table, the ID is automatically assigned by the database. Okay, in principle, or typically you'll find that those IDs are integers and that they're increasing. Many database systems allow you to control exactly what happens there, and there are instances where IDs are actually GUIDs, also pronounced GUID. That's kind of like a little cultural war that we have going on at where I work. Whether it's GUID or GUID, I like calling it GUID. But anyway, globally unique identifier, which is really a string. So some databases will use GUIDs to identify records, but very often you'll see that it's integers. You'll notice that when we go to insert something into our customers table, for example, we don't specify the ID. That's for the database to manage. When a record is created, the ID for that record will always remain the same until the record's deleted. It's assigned by the database and will always remain that way. But we might want to say, you know, let's, in fact, let me return all of my customer fields so I can see what they are. Okay, so now if I want to insert, in parentheses, I can specify what fields I have values for that I want to add. Let's say I know the customer name, I know the contact name, I know the city, and the country. And so now, after I've indicated what values I'm going to provide, I need to actually provide the values. So in this instance, it's the SQL statement values. I'm going to go ahead and capitalize these just so it's easier for you to tell what's my data and what's not. Okay. And then in parentheses, I can say, let's say the customer name is me. Contact name is the boss. And then the city is Anytown. And the country is, I like visiting India, so I'll put India. Okay, so the order that these values show up here are going to match the order of the fields that we've specified there. So when I run this statement, what I should get back is the number of rows that were added or impacted in the database. So you can see it says rows affected is 1. So what might I do if I want to actually see that record, right? So I'm going to do a select statement. What could I do here to ensure that I can see it? The new one that I just created. Okay, so I could just select star from customers and then scroll all the way to the bottom. We can see my record there, right? If I wanted to be clever, I could also tell it to order by the customer ID descending, and that'll put my new record at the top, right? Assuming that the IDs are assigned sequentially, the most recent one is going to have the highest record number or customer ID. And so when I do that, it's sort of in reverse order by the customer ID, it'll put it at the top. Okay, good. Robert says where customer name equals S. Kirkby. So I could do okay, so put a filter in place and it'll pull that up. Very good. Good. And yeah, limit 1. Dave, that'll work if I've got some kind of other filter that will indicate it. Otherwise, it's just going to start at the beginning of the table and return just the first one for me there. Okay, very good. Okay, let me give you guys a chance to kind of play around with this. I'll give you a quick in-class assignment again. Okay, there's the assignment. So if you've had a chance to do that, just click on the poll to let me know so we can move on. Scott asks, how does it know to add 1 to the ID? That's a great question. That's pretty much a standard default when we're using integers for IDs, which is the default for almost every database system. Again, it is possible to customize that, and different database systems have different methods for customizing that. We won't dive into that very much because it's complex and a little bit kind of on the outskirts. Not very many cases where I've seen where the ID needs to be different than an integer, but it depends on the number of records that you're dealing with, right? Because when you're dealing with an integer and it's only positive integers, if it's a 64-bit integer, there's a limit to how much you can add to how many records you can add to the database. And if you need to go beyond that, then you may need to look at an ID that's in a different format. And there are other reasons why, where you've got distributed databases where you want to use a GUID that's globally unique instead of just being unique within that database. So that's another reason why you might need to use something different. But for the most part, they will use integers, and they will always increment by 1. So Robert asks, can you do an insert and then display the new entry? Insert typically will return a value to indicate how many, because we can't do an insert with more than 1 record at a time. And we'll get into that when we look at the Connect system. What insert's going to return is an indication of how many records were added. So if you want to display them, you would have to turn around and do a query to retrieve them, and then you can display them. Yep, exactly. Okay, Kenichi says you're getting an error. Select star from customers, limit 1. What's the error that you're getting? Yeah, it's interesting, Kenichi. I'm not sure why you're getting that. Syntax looks right based on what you've typed in. Syntax error in the from clause. Yeah, I mean, if you had the table spelled wrong, you'd get a different error. You may try just refreshing the page and typing it in again and seeing, maybe click on the restore database if there's maybe a problem with your table. Let's see if that will fix it. And Ollie asks if we need to put a semicolon at the end. Some systems will require it. Many of them don't. It is technically part of the SQL standard to put a syntax at the end of your statements, but not everybody requires that. During a break, we may need to dig into that a little further. Kenichi, I'm not sure. It looks good to me, but there might be a problem with your database. You can try restoring it or refreshing the page and seeing if that'll help. Okay. Looks like we've got almost everybody ready to move on, so let's do that. Joshua asks, do employers look for the semicolon at the end of your code as good practice? Some might. If you're being interviewed by somebody that's a data aficionado, they may be really picky about that, as well as capitalizing SQL statements and so forth. The level of fastidiousness with which you'll find among people just differs. I find that I don't have a religious preference for the semicolon or not, but that it should be consistent. Whatever it is that you're doing should be consistent. Generally, when you're using a number of different third-party tools to help generate and process SQL statements and customize them, it's a good idea to include it. So it's probably a good practice, but it's not always required. So it just depends on what environment you're working in. Tabs versus spaces, exactly. I'm not going to say where I follow that front, but I know the argument well. Okay, you bet. Okay, Kenichi, we're going to have a break here in a little bit, and I'd like to dig into that with you a little bit if you don't mind. I'm not sure what's happening there. All right, let's move on to the next statement, and it's the update statement. So we've talked about the C statement for creating new records. We've talked about R for reading, and then U is for update. Basically, you know, this is how we modify data that already exists in the database. And the keyword that we want to use for SQL, again, is update. We want to follow the same pattern. We want to specify what table we're updating. And then we specify how we want to update it, right? So we might, for example, say, set the city field equal to a particular value. Okay, so maybe we'll say West Valley. Okay, so what would happen if I were to execute this statement here? Okay. That's right. It will update all the city values for each of the records. So I'm going to go ahead and run it. You can all gasp in horror as it shows that I've updated now 92 records. All right, so whatever those cities were in there, they all now say West Valley. Okay, that's a problem. So I'm going to click Restore Database because I don't really want it to be that way. Now you can see they're all restored back. So what do I need to do to, you know, let's say I want to update the city for a particular record. How do I limit the statement to that one record? Okay, Morgan says, yeah, as he says, my admin's going to be angry. That would be bad. But if they got to get data back up, I had a friend I'll just tell you this quick story. I had a friend a long time ago that worked back when system analysts were kind of a thing, and his company used a mainframe. I shouldn't say he was a friend of mine, but he was actually the father of a friend of mine. But I got to know him, and he's one of the reasons why I kind of got interested in the industry. But he told me a story once that he made some mistake that cost the company $20,000. And his boss called him in to talk to him about it, and he walked in and said, well, I guess I'm going to get fired. And his boss said, why would I fire you? We just spent $20,000 training you. And he learned a lesson there that he better not make that mistake again, because they assumed that he would know better from now on. I can't guarantee that would always be the case, and you'll have somebody that understanding, but making mistakes is part of learning, so it's not always a bad thing. Yeah, so somebody said where, I think it was Morgan. Yeah, many of you said where parameter equals criterion. So if I wanted to update customers table, and I want to set the city equal to West Valley, I need to put that in quotes, and I would use the where clause for the ID equals, let's say we want to modify number 3, the lucky winner. And you'll notice the error says it's not ID, it's called customer ID. And it says here my one row has been affected. And if I query that, you'll see that it's updated now, my statement there. Okay. All right, next we're going to talk about the D in CRUD. So we talked about create, update, we talked about read, and so the next statement is simply delete, right? And again, we need to specify what table we're going to delete from. So what would happen if I ran this statement? Destroy. Awesome. In CRUD, I always choose delete because of SQL. Many people will like it to call it destroy, but I always call it delete just because it's what it is in SQL. It all gets deleted, exactly. Boom, ouch. Right, so if I were to run this, you'll notice over here on the right, the number of customer records in my table is 0. It's okay though, because I could just go to another window, right, and open this, and then, oh, wait a minute. My customers table is still empty. Does anybody know why? Okay, restore database, exactly. So remember what I showed you before. If I go into developer tools and application, this database that's stored locally in the browser is there for all tabs, in all instances of the browser. So when I blew it away in one tab, it's gone for good. The restore database button, which is thankfully provided by W3 Schools, is the only way I'm going to get that data back. Or I could restore from a backup if I have one. Or I can go through and add them all by hand again, but there were 91 of them, so I don't want to do that. Data persistence, exactly. That's exactly it. Okay. We're almost exactly on time. We're making good progress. Does anybody have any questions or issues that you want to address before we move on? Jason said he learned the hard way you have to have good backups. So that's a hard lesson to learn. Couldn't you clear the browser memory and make it download again? Yes, you could. When you do the clear browser things, it can get rid of local storage as well. And then when you refresh the page, it would re-download it. So that's a good call. Yeah, clearing the cache, exactly. So Izzy asks, will we talk about data types? We're not going to dive too deeply into that. That's also a thing where you'll find different databases. Different database systems will have a number of different database types that you can dig into. There are some standard ones that you can count on almost everybody having, including things like bitmaps and blobs, which is basically just a bucket of data, of binary data. A blob is an acronym that stands for binary large object. To different types of integers, GUIDs, strings, characters, Booleans, different ways of representing Booleans. There's not necessarily a standard, and this is one of the reasons why something like Connects could be really useful, because it allows you to specialize in the business logic without having to dig into the nuances of data. If you're going to target your application to a particular database, then the nuances, can be a good thing, and you can hard code those nuances in. But something like Connects can buffer you from that, can separate you from that concern. So that's why it can be really handy to use a query builder and a database layer like Connects. So short answer is we're not going to dig too deeply into a lot of the different data types, because it can get pretty hairy, but definitely a good topic to learn about, and just be aware that different database systems are going to have some differences in how they define different data types, the sizes of them. That's something I always try to look for in documentation when I'm writing against a particular database system, so I understand what the environment is and what the edge cases might be, where I might run into trouble with object sizes and so forth. So it's a good question. Randy asks, storing the data in the local cache. It's storing it in the browser storage. I think you might call it the local cache. The browser is going to have a different area called a cache that it uses for web page objects. And it also has a different area called browser storage, which is, there's different kinds of storage that your browser is going to keep and make available for you. And there's different standards for accessing them. Web SQL or Web SQL is one such standard that's kind of been deprecated. It's been replaced by another standard. In fact, you'll notice it if you look here. We've also got indexed DBs. That's kind of the newer standard that overtook Web SQL, but Web SQL is still in use by different people. But yeah, this is an area not necessarily called the cache, but it's called browser storage. We are going to learn about joins, but we're not going to become experts on them because it can get really complicated. Not that you shouldn't know it, but the scope of this class is not going to dig too deeply on that. That being said, if you've got some well-formed questions about inner and outer joins, I'm happy to broach that topic a little bit. But I do want to stay on topic. We're not going to go over it today for sure, but it's a good question, so keep it in mind and don't be afraid to ask me about it later. Okay. Good. Are there any checks in the wild to keep people from completely messing up DBs? I'm not sure what in the wild means or what checks means in the real world, okay, in real life. That's a good question. The bigger and more sophisticated a particular system gets, you'll find different structures from a database access perspective, as well as from an HR perspective that can help alleviate that. I know that at many companies, they'll have an entire group of database administrators. There's an entire kind of subsystem that we're not going to get into where something called stored procedures, which is little chunks of code that can automate different database operations that are more complex that can get executed. And it's helpful to database administrators for you to, and in this code, by the way, they're called stored procedures and they're written in SQL, typically Transact SQL, which is a variant of SQL. And database administrators like to get that ahead of time because they can tune the database to be very efficient at running those things. But my point is that in some of the, many companies, database or developers won't be able to deploy a stored procedure even without it being reviewed by a database administrator to confirm that it's accurate and not going to do something serious. So, everybody does it differently, but if you're working for a company that knows what they're doing, they're going to have plenty of checks to ensure that you don't mess things up. And at the company that I'm working at now, new developers have to go through a period of proving themselves before they get access to do certain things that involve our data. And even then, our database administrators always have a look at everything that happens just to make sure that it's on the up and up. So it's always helpful to be aware and have some expertise in the data realm because it makes you a better developer. It makes you more aware of what's happening and helps you understand why certain policies might be in place. And you don't have to code in fear. You can actually be, more confident in what it is that you're doing. But if you're not a database expert, that doesn't mean that you aren't going to be able to work with data. You'll likely have other team members that'll be able to help you out. Privileged user access, exactly right. Restricted users. Database administrators are a big part of it, yeah. Mandy asks, like having a test before you manipulate the DB, and in many cases that test becomes a part of the job interview. So it's just, again, it just depends on what they're looking for. You might not always be a perfect fit for what somebody needs, which is fine. There's plenty of opportunity. And we can always dig in and increase our skill set. Find an open source project you want to contribute to and start getting some experience in it. So good calls. Yes, and often there's many copies to practice on that are not production. So that's exactly right. Okay, let's move on. Let's see, it's 8:21. We still need to cover delete, and then we'll take a quick break. So actually, did we? Yeah, we already talked about delete, so we're through that. Okay, so did I restore my database? I did. So if I wanted to delete a particular record, just to go back to the delete statement, I can do delete from customers, and again, use the where clause, right? So I delete that record where ID is 1, and then if I it says that one row is affected, and then if I do a query, you'll see that my ID 1 is now missing. Yes, I deleted the entire table. Thank you. Okay. All right, let's go ahead and take a 5-minute break. And then when we come back, we'll jump into connects and query builders. So Josh, you're asking, why doesn't the customer ID update and show number 2 as number 1 now? And that's a great question. I appreciate the question because, as I mentioned earlier, these IDs, when you add data to a table, the IDs are created by the database system, and they stay with that row forever. It never gets modified until the record is deleted. So this particular record that has the name Ana Trujillo Emparedados y Helados. I don't speak Spanish, but I think I might have got that right. This record that has all this information in it has an ID of 2. If somebody else, if some software system had taken that ID of number 2 and stored it somewhere, thinking that it belonged to that record, but somehow later the customer ID was updated just because some other system or person did a delete, then it would mess things up, right? So we want them to stay the same, and the database is going to protect that for us. So I deleted the record that had an ID of 1, and now that record is gone, but all of the other records retain their ID. Yes, integrations would not like that. You bet. Christina says search for Cascade. That'll be an interesting topic. That's a good idea, Ernesto. Kenichi, thanks for tracking that down. You were using Firefox, and now that you're using Chrome, the limit error went away. That's interesting. I'd like to understand why that is. I wonder if it has to do with the way Firefox has implemented their SQL, their web SQL engine. That was a good find, though. Glad. Robert, thanks for calling that. I'm sorry, I should have muted before I drank that water. I realized that probably sounded bad. I'm still a noob with the mic, so I make rookie mistakes like that all the time. And by the way, I'm actually glad to be doing this session from the beautiful state of Connecticut. I'm not at home tonight. That's why my background and microphone looks different. I'm helping some family members move in up here as my son-in-law gets ready to start school up here. So. Yeah, Jason, that might be true. Yeah, Mandy, I like it as well. In fact, at home, I've got a mechanical keyboard. I like the sound of it. It just makes me feel like I'm actually making something when I can feel the clicks and hear them, and I don't know, there's something oddly soothing about it. Yeah, I highly recommend them. I'm a touch typist, so I like 98 words a minute, so um, I'm kind of picky about my keyboards. I have Browns, Cody. I've got a Philco Ninja 2 keyboard with brown, cherry brown switches on them. Blues are a little too clicky for me. All right, but that's why I'm glad there's so many. Yeah, I'm glad there's so many different types, because there's so many different use cases and people that want to use them. All right, welcome back, guys. Now we're going to dive into query builders. So we've talked a little bit about how different database systems can implement SQL and different nuances of syntax differently. And what we'd like to do, if we're not going to be a database administrator, but rather a software engineer, which is a related but different field, we'd like to be able to focus on the business logic of our application and integrations of our application without having to also be an absolute expert on every little detail of every database's syntactical nuances. Query builders can be helpful for that. What you'll find as we kind of dive into Connects is that it allows us to create these same SQL queries that we've been playing with, but to do it using JavaScript syntax. There are some differences. It's a little bit of a different way to think about it. But I'll actually show you something about Connects that I think you might find useful to kind of understand what it's doing in the background. Connects is a database or a query builder for JavaScript that is compatible with a number of different database systems. If you want to follow along, you can go to the connectsjs.org website, which has the documentation. And if you look in the upper right-hand corner, there's a little drop-down that gives you an idea of the different kinds of databases or database systems that Connects supports. There's Microsoft SQL, Oracle, SQLite 3, which is what we're working with, Amazon Redshift, PostgreSQL, and then MySQL, and the MariaDB. So each of these is going to have some differences, but when we learn to write queries and interact with data using Connects, we don't have to worry about what database is being used in the background. Where we mostly have to worry about the database is when we specify the connection criteria. So you can see an example here of a connection to MySQL, which specifies a host name, user and password data, credentials, and then the database name itself. Whereas down here, the PostgreSQL connection has a little bit of a different set of criteria. And then yet again with SQLite, it's even different still. But that's where the differences kind of end, is when we're trying to connect to a particular database. The creation of different SQL queries using the Connects syntax is the same no matter what database we're using, and that's one of the things that makes it so powerful. Okay, so what we're going to do, if you've got your repo downloaded, we're going to dive into this. I like using Yarn, so I'm going to delete my package lock JSON file so I don't have to see all of that. And if we open up the package JSON, you'll see we're using Express and NodeMon. If we were to try to run this, well, we'd have some issues because there's some dependencies. If we look at the index, you'll see we've got a require for server.js. And if we open that, then we'll see that we're requiring our post router, which is in the posts folder. If I open that, you'll see that this is requiring the db config file, which if I open that under data, you'll see that this is requiring connects, right? And then when we do require connects, we're passing into this config.development object, which is coming out of this connects file, which specifies SQLite 3. So somewhere along the way, connects is going to have a dependency on SQLite 3. So there are two packages we know that we need for this system to work. One is connects and the other is SQLite 3. So in order to make that happen, I'm going to open up my terminal. I like it on the right. And simply yarn add connects and SQLite. There's only one L in SQLite, by the way, 3. This will take a little bit of time. Okay, and now we're done. So if we go back to our package.json file, you'll see that we've got our dependencies in place, and we should be able to execute our server now. We've got our server script. So if we run it, so we're listening on port 4000. Okay. All right, so what we want to do now is, let me just take you through briefly the different components that are making this work. Okay, we'll start at the beginning. If we look at index, we can see we've got our files are separated the way that we've learned how to do when we did the router sprint before. So we're requiring server, which is where our Express server is being created. And as part of that, we've got all of the posts APIs are in our post router. And here is our server.use that's binding that post router to the /API/posts URL, base URI. And so inside this post router is where all of our code for the posts API is going to exist. And you can see here where they've got placeholders for us to do our work in already created for us. But as part of our class today, we're going to fill this out, right? And within these, as we've seen before, it's within these handlers for these different URLs where we actually interact with the database. We go to the database to get our data. And so because of that, in this file is where we're creating our database object. And we do that by requiring the db-config file, which is exporting connects. And our connects method is coming in because we're requiring that module, and we pass to it a configuration object. Now we could have done this configuration object as a JSON object in this file, but it's good practice to keep it in a separate file, and so you can see that that's what we're doing here. If we look at the connects file, all it does is define a JSON object and then export it. And the object has a property inside it called development, and this is where all of our settings for SQLite 3 connection pointing to our database exists. So here in the config file, we're bringing that in, and then we're exporting connects with that configuration to our router, which allows us to access our database. Okay. And so in the past, we've had different helper files that interacted with connects for us. In this case, we're going to be dealing with connects directly. Okay, so when we write our code, for example, to get our API posts data, we'll be using a connects method directly. Okay. All right, so our first order of business is to take a peek at creating code for this get method. What we want to do here is return all of the posts from our posts database. So by the way, if you look under the data folder, you'll see that there's a posts.db3 file. That is our database file. And it's a binary file that has our tables in it. It may only even have a single table, but how that file got created is something that we're going to learn about later. We're not going to cover that tonight. But to create an empty database and then create tables, so we've talked about how to create records in tables. There are other SQL statements that you can use and will use to create actual tables. So you can create an empty table and then specify what the structure or schema for that table will be. So somebody at some point created this database file and then specified for every row in a particular table that there's going to be what columns are going to exist in that. And so it's already been defined and pre-populated with some data for us, just so we can kind of focus on working with Connects and getting at the data that's in it. But that is something you'll learn, is how to start from scratch with a 0-byte database, create the shell for that database, and then add tables so that you can start adding data to the tables. Okay, yeah, the format of that file, every database system is going to have its own format for how it stores its files, based on how they work. This is a pretty simple and straightforward database file. If you want to dig into SQLite and what its limitations are, typical use cases, it's a great little database for local data. It has other uses as well. But when you just want a place to persist data locally, it comes in handy. It's really handy for that. Okay, so let's get into creating a get method for returning posts. So inside, we'll give you kind of a peek into the database. There is a single table in it, and it's a little confusing that the database name file name is called posts. And then when we start doing our queries, we're going to return data from a table called posts. Don't be confused about that. There is inside this database file, there is a table called posts. And that's the thing that we're actually going to be pulling data from when we create our SQL queries. It's not referring to the file, but rather it's referring to a table in the file. And that, by the way, that brings up something I wanted to point out. When you're working with SQLite 3 and you go through the syntax of creating this connection, which, by the way, the documentation for this is in Connects and it's pretty straightforward. You want to specify the file name for where your database is. This is a relative path that's relative to the root of the repo, not relative to the location of the Connects file. So keep that in mind as well. Yeah, I love that meme. That's awesome. Okay, so let's get back into our router file, and we're going to build a get method here that returns. And you'll notice that, and I should also mention, by the way, as well, that the Connects API are basically the list of methods and that you use to interact with the data is a promise-based API. So when you make a call into Connects, it will ultimately resolve or reject, depending on how things go with the request. But there's another interesting property of the Connects methods that I'm going to point you to when we get to it. But the reason why I'm mentioning this here is that I actually prefer the async await syntax because it's more clean, like JavaScript for me. So in order to do that, I need to put the async keyword in front of my inline method here. And so there's code that I'm going to put in, and basically what this is going to do is remember that DB is the object that's being returned by my DB config.js file, which ultimately is just connects itself, right? So I'm getting connects back with particular configuration. And so when I do DB and then posts, there's another syntax I could use here. Okay, and that syntax would allow me to specify in kind of a change format something that's very similar to an actual SQL statement. Okay, that should look familiar. Select star from posts, right? In connects, this is just a shorthand way of doing that, right? So if I just call DB and then pass in a table name, it's going to assume I want all the columns and that this is a table name. You might find it more comforting or to help you keep your mind straight about exactly what it is you're doing until you get really familiar to use this form of the syntax. I'm going to leave it in here as a comment, but these are equal. They work exactly the same, okay? So what this is going to do is it's going to return my post, and because I'm using the async syntax, I want to put this in a try catch statement. So let me pull these up. Okay, so I've got my post, reading it from the database, and then I'm going to set my status and then return it. Okay, and then I'm going to do a catch for any errors, and then set my response status to 500. Okay, so this should implement a getter for the root of what this router is bound to. And again, if we go back to server, we'll see that our router is bound to /API/posts, right? So I'm going to come over here and save this, see my server restarts, and if I go over to Postman, I can now do a get localhost 4000 on posts, and then you can see it'll return all of my data. Okay. Now, one thing I want to kind of just take a little bit of a sideways look at this, and in order to kind of show you something that I know about connects, and this is actually kind of helpful. Before I call await, by the way, when I use await, it's basically saying make this call, but execute the code that is returned in the resolve. But something else that I can do is without the await keyword, I can set the return value of that method to a variable. And then let's just put it out to our console log here. Okay, let's just take a peek at what that looks like. If I come over and do that, that is not what I was looking for. Give me just a quick second. I deleted all my tests. I'm going to have to come back to that for you because it's not, I think, yeah, it's not returning what I thought it would. When I did it before, it actually returned the SQL query. During a break, I'll dig out why this is doing this, because this is the first time I've seen it do that. But there is a way to get it to show you the actual SQL query that would come back, that it's actually sending to SQLite, which is kind of handy. So I'm going to take this out for now. So disregard that. That's what I love about doing this thing live, even though I've practiced it a million times. But in any case, hopefully you get the idea here that using the await keyword, we're calling into DB. We're getting all the columns from post. It's being returned as a JSON object, which we're then returning to our client here. Okay. All right, so what I'd like to have you do, and I'll type this in so everyone has access to it. Write the get handler for API posts ID, so that it will return a post for a particular ID. Okay, so using the same sort of method that I've used here, we want you to implement this method. Okay, so I'm going to put in a poll to have you indicate whether you're ready or not to move on. We'll give you a few minutes to get caught up on that. So a question was asked, why do we sometimes use try catch with async and sometimes we don't? When you're using async and await, you should always use try catch. If you're not using async and await, then the syntax, in fact, I'll make a copy of this just so that you can kind of see this. And this is for those that are not working on your own things. Hopefully this won't be too distracting. If I didn't use async and await, then instead of try catch, we would use the .then .catch syntax for promises. All right, let me restore that. There we go. So we would do it like this, where you do .then, and then okay, so you would just call it directly like that, and then you would also do your .catch. I forgot to put this in brackets here. So hopefully that makes sense. So if you're using the async and await, then you want to use the try catch. This is basically code that would fit into your .then clause if you're using the other syntax. And then this is code that would be in your .catch clause if you're using the other syntax. I personally like it this way. It's a little easier for me to read and understand it, but hopefully that makes sense. You bet. Okay, so if you get done, go back to the poll and indicate yes so that we get an idea of where everyone's at. Again, the instruction is to implement your getter for a particular ID. Okay. All right. Looks like everyone's ready to move on. So let me go through what the potential solution to this would be. First is we need to retrieve our ID from our parameters. This is from the URL. It's been templatized here. And then we're going to make a call into connects to the table using our syntax. So this is, basically, again, consider this to be db dot select star from posts where ID. And we'll take a look at the connects documentation here for just a second. Look at the different types of syntaxes you could use for this where clause. This is one of them, where we just put the ID in, and because it's in a JSON object, it's going to essentially default to the ID itself being equal to that value. We'll look at some other syntaxes that might be a little more clear. If we get a response back, then we're going to set our status to 200 and return it as a JSON object. Otherwise, we'll set our status to 404 and then send back an error message. If connects throws an error, then we're going to send back a 500. And by the way, this is really kind of a catch-all. We could do a lot more to make our error handling more specific here. In some cases, connects could throw back an error that should be a 400 class error, not just always a 500 class error. Again, remember that 500 class errors typically mean there's something wrong on the server that no matter what the client changes, it could never be, the client can't fix it. Let's see here. So in any case, this is just kind of a catch-all. But this is one way to implement it. Questions? Why is there brackets around post? And Dave's got it right. It's like it is a destructuring from the object, but instead of destructuring from a JSON object, you're destructuring it from an array. Okay, good. All right, so now that I've got that, I'm going to go back to Postman and give it a try. We'll try for posts number 1. And sure enough, we got it back. If I were to put an invalid post ID in, then we get the right error back. Okay, good. Okay, looking at the poll. Looks like everybody's ready to take a break again. Before we do that, we've got a few minutes. Let me ask if there are any other questions about what we've covered so far with respect to connects. Hopefully you've been able to follow along as we've shown how it gets used in your application. and how we can use it to build SQL queries. So Robert, in terms of tips for understanding the logic for this, the best thing I could say is practice, practice, practice. Look at other people's code. Look at the examples. We'll go back to the Connects documentation a lot is what I tend to do, and then use the community. We can totally support one another with respect to that. There's a connection that will come and the light will go on. You'll understand the connection between SQL statements and basically what we're doing here. I want to take this break here to see if I can get that the work I did before to actually be able to see the query, because it was very helpful to me to see exactly what Connects was doing. It's basically just building an actual SQL statement, using the nuances of the language or the database that we're actually connecting to. And so similar to what we were doing in the web browser, that's basically all Connects is doing. But the syntax is a little bit different. It's a JavaScript syntax with the chainable method calls, and the documentation will be very helpful in terms of understanding that. Good. So Paul asks, do you need where? Yeah, Ernesto, that's not quite it. So I'll dig into that and see what I can find. I had it working a second ago before, but I'm not sure what I'm doing wrong. I get this fog when I get into presentation mode and I start forgetting things. So I apologize about that, but I'll get back to it. Did you need where? That's how you get back the post of a specific ID. That's correct. So if we didn't use where, we would get back the entire list of posts, right? So if that's not what we want, then we need to include the where clause. So again, one of the reasons why I kind of like this syntax is it reads very much like a SQL statement. And Robert, maybe this will be helpful to you to understand what's happening. It is building a SQL statement that is like select star from posts where ID. So it's going to look very much like and then whatever the ID value is gets put into there. So this statement for Connects is going to end up looking like this at some point, where it passes this actual SQL statement to the engine that's dealing with the SQLite database, right? So this is just a way for us to build that, have Connects build this SQL statement using a chain of commands. And there's some shortcuts that we can use, as I mentioned before. That's not what I want to do. Let me get rid of this and that, so it'll be easier to see it. The other syntax that we could use here would be like this: await db posts dot where ID. Okay, this part right here is shortcut for this. They're the same. And then I mentioned before that we'll take a look at the documentation for Connects. If we look at the where method down here under Query Builder, you'll see that there's an object syntax where you can pass in an object, which is what we're doing here. So you notice the curly brackets. That's what we're doing here. But it's kind of a destructuring type thing where we've got ID colon ID that gets passed in. The other option that we have is we could use a key value syntax, right? So if I wanted to, I could change this to the actual field name and then the actual value name, right? So there's that option. And then we also have the ability to pass it a function. We won't talk about that. It can get a little bit complicated. Likewise with this chain, you can dig into that if you would like to learn more about that. But this operator can be helpful because it's a little more explicit, right? So if I were to come in and say where ID equals ID. Okay, so you can kind of see how it's building our query here. Select star from posts where ID equals ID, and then it ends up with this statement. All three of those options that we just looked at will do the same thing. They're just different shortcuts for how to do that. Sometimes I find that working with the more explicit long cut, so to speak, is helpful until I become very familiar with how the system is working, and then I'll start digging into the shortcuts. Otherwise, I can kind of get lost with what's happening behind the scenes because they're hidden. If you use shortcuts, you don't really get to see everything that's going on. So hopefully that'll be helpful. So Corey, that's right. You can just say dbposts.whereID. Okay, and Ollie, you're getting a 404. And Douglas, I think, has found your problem there. You're missing the /API/post. So remember that in our server file, all the stuff that's in this router is going to be prepended with /API/posts because here in the server file, we're binding the router to that base URI. So everything that's in the router is only going to see stuff from Express if it's preceded with this because of this server.use. Okay. Now, Ryan, you may want to check the same thing. Just make sure that when you're doing the tests, you're using /API/posts in the URL. Oh, I think I stopped my server. Oh, here. Oh, I've got bad code here. There we go. Okay. All right. Let's kick off a break, and then Brian will dig into the issue that you're having there as well. Let me get to my browser so I can get the timer started. And I'll leave this code up for those that are still working on that. Yeah, so Ryan, post your code. Okay, so where you've got post in curly brackets actually needs to be in square brackets. So destructuring is an interesting topic in JavaScript. If you're doing it in curly brackets, it basically says if you've got a JSON object that has an ID, a property, with an ID that's equal to what you've got in the curly brackets, then take its value and create a variable with that same name to be used in your JavaScript code. In in array destructuring, it works a little bit differently in that it's positional, and you're basically saying take the first value of the array and assign it to that variable. So because the array for the syntax for arrays is square brackets and not curly brackets, you need to change those curly brackets around where it says const post need to be square brackets and not curly brackets. So you're hitting your 404 because your post variable is not getting a value because of you've got the wrong syntax there. You bet. Dang. I spared you guys listening to me drink water, and then I rambled on for like 5 minutes, and you didn't even hear a word of it. Unfortunately, I don't remember anything I said, so we'll have to start over. Kenichi, I was just saying I'm not sure why that is different for you. I'd like to dig into that. But getting back into our next step, we're going to talk about creating or inserting data into our database using our API. So here we're talking about the HTTP method post. It's a little bit confusing because we also have a table called post and a database called post. But here we're talking about using or handling the HTTP method post to put data into our database. So we're going to assume that when somebody calls our API, they're going to pass some data in. How do we get at that data? What do we need to do to get the data that they're sending in? And Paul, your statement is correct. You need to know what that thing is returning. If it's returning an array, destructure an array. If it's returning a JSON object, you have to destructure that. So Eric's got it. It's rec.body, right? So somewhere we've got a processor or we have a parser that's parsing JSON, and it's going to be here in our server that's taking JSON text that's coming in, the body of our request, and turning it into a JSON object on the rec object. Right, so we can access that here. So we're going to do post data equals rec.body, and then we need to try to see if we can add it, right? So the connects method that we use to actually insert data is just called insert. So again, the chainable method names that connects uses are similar to the SQL statements that we've learned earlier. So we want to insert the data into that table. So this is the method or the syntax that we use. If we go and look at the connects documentation, I'll search the page for insert. And we can see that it creates an insert query, either taking a hash of properties or an object. And in our case, we're passing in an object. And we're assuming that that object was given to us through the body of the API request. So we're going to expect that whoever's calling our API is sending in a JSON object that we can just pass directly into the connects insert method. If there's something wrong with that, then connects will reject it, and we'll end up down in our well, connects can handle it in a couple of different ways. It could return a null value for post, which we can handle, or it could do a reject, which would put us down into our catch phrase. In this case, we know, I think that if there's something wrong with the post data, we're going to end up with a reject, which is going to put us down into our catch method. So we'll assume that if this works, if the insert works, that we can just return a status. We're going to use a 201 for created data, and then for JSON, we'll send back the post itself that got created, because that's what's going to get returned here. If there's an error, then we could do some error handling. In this case, we're just going to assume that there's a problem that we're just going to send back a 500 to keep it simple. Probably make this a JSON object. Okay. So that should be all we need for our post to be able to create data. So to give it a test, what I'll do is come back over to Postman and I'll take a peek at what gets returned when we retrieve data. And I can see there's an ID. Again, when we're creating data in a database, we don't supply the ID. The database creates that as it goes. Likewise with these dates, the database is going to create those for us. So the only two pieces of information we need to supply when we do a post is title and contents. Okay, so I'm going to do a post to our API. I'll choose body. Remember, we have to insert a body, choose raw, and then choose JSON as the type. That's going to ensure that we have a header indicating to Express that this body is JSON. So that the express.json method actually gets called to, or will actually handle it. Again, because we're passing in JSON text, we need our property names to be in double quotes. And we need a title. And then we need some content. We'll keep that simple. And then when we send it, it's contents, actually. I misspelled that. Okay. Then when we send it, we get back an array with the IDs of whatever was added. Right? So I could have passed in an array of different objects that I want to create if I wanted to do more than one, and I would have gotten back multiple IDs. But in this case, I only get an array with one object in it because I only added one item. And then if I want to verify that that's the case, I can do a get. Scroll down to the bottom, and we'll see my new post here. Okay. If I were to change the name of one of the fields and make it incorrect, oh, I need to do a post, sorry. Then I'm going to get back an error that says you cannot add your post. So we know that what Connects did in that case was it rejected in the promise instead of resolving it, and sent me down to this catchphrase. Okay. Any questions about that? I'll give you guys a chance to catch up. Let me know if you're ready. Click no if you're still working, and then go back and click yes when you're done. Looks like everyone's keeping up, so we're in good shape. All right. So next, what we want to do is we want to do update and delete. So I'm going to take you through the update, and then as an in-class assignment, I'll have you guys implement delete. But don't start on that yet. So you can kind of follow along with the update, and then we'll finish up. So what I want to do when I'm doing a put, in order to update a particular record, remember it's very similar to both a post and a get, in that I need to specify a particular ID, but I've got to get a body that has changes that I want to make to it. So I'm going to need to get both of those off of the rec object. So I can dereference the ID from the params property of the rec object, and I can get the changes from the body. Okay, so that's going to give me the objects that I need to work with. And again, I'm going to make this an async syntax because that's what I like. And in my try phrase, I'm going to get what I know about connects is that when I do an update, it's going to return the number of records that was modified, right? So I'm going to get a count, and I'm going to operate on the posts table. And I'm going to do this syntax just to keep it simple. And so I'm filtering and saying I only want to modify records in the posts table where the ID equals the ID that I got. And then what I want to do is update it. Okay, so again, this is the same SQL command that we learned before. It's the same as the connects method name. It's update, and all I need to do is pass in my changes. And again, similar to the where clause, update can take an object that just has the properties that we want to modify. Okay, so in this case, I can check and see if count has a value. If it does, then we know that we succeeded, right? So then I can do 200, and I'll send back a JSON message that just includes the number of objects that were modified. If count doesn't have a value, then what could we assume is the problem? So keep in mind that when we did post and the body was messed up, it actually rejected the promise. And so we ended up down in our catch area. In this case, we're not down in catch yet, right? So I'm going to put this down here. We can assume, or infer, I should say, that in the update method for connects, if the problem is in the body, it's going to do the same and put us down here in catch. Here we're handling a problem that's not that. It's a different problem. So, and it's one that we've seen before. What could the problem be in this case? Okay, it does not exist. 404 not found. The ID is invalid. That's exactly right. So we'll end up in the resolve area of our promise, which is this try block here. It's being resolved, but it's being resolved in a way that indicates to us that there was a problem with the data that was sent in on the URI. So here we're going to say 404, and then we'll send back a message. Okay, we couldn't find that post. Otherwise, if we end up down here in the catch, we could do, again, more sophisticated error handling, but in this case, we're just gonna, just to keep it simple, send back a 500 with the JSON object that has a message that indicates couldn't update the post, and just to be helpful, we'll include the error object itself. So anything that we get back from connects in that error, we'll be able to send that back in the API call. That's not always a good practice, by the way. Sometimes you want to process and filter and modify what you're sending back. In this case, I'm just for expediency, we'll send it back raw. Okay. All right, so this is our put method. And to give it a try, we'll change the one that I created, which is number 13. Let's fix our body here. We'll call it an old post. And we'll try to modify it. Oh, I don't want to do a post, I want to do a put. And then you can see we got a JSON object back that says we updated one record. So now if I go to get that particular record, you can see it changed my data. that is now persisted in the database. Okay, so again, we pulled our ID off the URL, we pulled our changes off of the body. We call dbposts.where the ID is equal to the ID that we want. And again, the other syntax for this, and I'll just put this in, is we could have just passed in an object that had the ID in it, like that. These are equivalent. And then we just called update and passed in the changes that came from the body, which is a JSON object with our changes. If we get a count back indicating that something changed, that's Connex's way of telling us that something changed, we can pass back to our API client a 200 and our updated count. Otherwise, we'll assume the ID was wrong. We'll pass back a 404 and say we couldn't find that post. And if there's something wrong with the body or some other problem right now, our catch-all is to send back a 500 and then pass back the error. Okay. All right, so now to finish up class, we've got a few minutes left. Let's have you guys implement the delete command, okay? And you can look at the Connex documentation to kind of find delete, you know, how we might delete. So look for what that might look like here. If I think that in a big chunk of documentation like this, that I might have some idea of what the method name might be, I'll just search for it. And it looks like it's called DEL. Notice that it says here in the documentation that it's, instead of just calling it delete, which is the SQL command, which would make sense, they had to alias it to DEL because delete is a reserved keyword in JavaScript. So the actual method name is DEL instead of delete, and that's the one you want to look for. Okay. Notice the syntax here. Table name. Don't forget your where clause because we don't want to clear out the table. And then you just call the delete method like that. So go ahead and finish up by creating your delete method. We'll put a yes, no up so you can indicate where you're at, and happy to field questions and help out. So Jimmy, you're getting a 500 on post and put. It's probably the body looks incorrect. If you look at this, you need to make sure that its title and contents are the field names, and that everything's in double quotes with the comma here in brackets, and also that you've got raw and JSON selected. That should probably fix that. Let me know if it doesn't. Can you take a screenshot or cut and paste it? Oh, you got it. Okay, good. Oh, titles, yeah. Yep, it's title. Title and contents. So Marco, yes, you can delete with the ID. In fact, that's what the delete method's signature, as they put it in the repo for us, shows, is that you need to pass in the ID with the delete method in order for it to work. Similar to a put, not similar to a post. A post doesn't take an ID, but the put does, as well as a get. Okay, it looks like everyone's ready to go. Ernesto, awesome. Thanks for looking that up. I was getting it without having to use those methods. I didn't even know those existed. But if those of you that are interested, take a peek at what Ernesto has posted. The .2 SQL or .2 SQL and .2 native will return the string that you're looking for, which is, again, to me, it's interesting just to see what's happening behind the scenes. What Connects is doing is building a SQL string, SQL query string, that is compatible with the database that you're connected to. And it uses the method calls that you're making to determine how that string should be set up. Keep in mind that the methods in Connects are designed to give you some flexibility. So there's more than one way to get there. We looked at the where statement, for example, or the where method. You can pass in an object, you can pass in an ID name as a string, and an operator as a string. You can pass in a key value pair. A lot of this is designed to allow you to use it in a wide variety of different applications that might be getting information from other systems that you can't control the format of it. So they're helper methods to allow you to do the same thing using a multitude of different methods. Okay, so I'm going to go ahead and type out the answer to this delete. Since we're a little bit over time, but this is the last thing we're doing today, so we'll see if okay, so we're getting our ID. Gotta remember to put my async keyword so I can use the syntax I like. And similar to the put, we're going to get a count of objects that were deleted in this case. So I'm going to do count. I'm going to wait on the DB. Posts. Put in my ID in the where clause so that I don't clear my table out. And then just call the delete method. If I got a value back for count, then I'll return to 200. And then a JSON object that has a message. Actually, we'll just say deleted. Otherwise, we'll send back a message saying we couldn't find that post. And then lastly, we'll do our catch in case Connects rejects our promise. Set our status to 500. Okay. And then to double check that this is going to work, I'll do a delete on my post. And I got my deleted. If I try to do it again, it says it couldn't find that post. So if I do a get for that particular post, it says it couldn't find it. And if I do a get for all the posts, we'll see that it's been deleted. Okay, let me just check up on the comments here. Corey says 204. That's probably the right HTTP result code to send instead of 200. You'll want to follow up on what the appropriate thing to do there is. I always have to look it up. My brain's not big enough to keep all of those details in, so I always have to look stuff up. Not sure what a banana word is either. So Dave did const count equals await dot delete ID, and it worked. Huh, interesting. Yeah, that's good syntax. Well, it's interesting. I wonder if the documentation shows anything like that. It doesn't. The thing that makes me a little nervous about finding hidden things that make stuff work is that because it's not documented, you never know if it's going to get removed or changed at some point down the road. So glad that it worked, but I would be a little anxious about continuing to use it because I have no idea if they're going to keep it that way. They didn't write it that way, so not sure. But I like that syntax better. I think it's a good way to do it. I would vote for them to keep it and just make it official. Okay. Banana word. I'm going to have to, those bananas look really sad. Okay. Okay, Ernesto, I'll put my code back up, and happy to stick around to kind of help close this out. If anybody needs additional help, thanks for sticking with me for an extra 10 minutes. We had a lot of material to cover tonight. You guys hung in there and stayed right up with me, and I think that's awesome. Great job. If you're still struggling and need some help, please reach out to the resources that you have. I'm happy to help out as well. And, again, I'll stick around for those that might need some help. Otherwise, I'll say have a great night, and we'll catch up with you guys on Thursday.